Okay, some more problems from section 3.6, and these problems are designed to kind of help you work through the chain rule, get a little more familiar with it. And the problem was that you wanted to find the derivative of the composite function, or the derivative of the composite function, f circle g, or f of g of x, that derivative at 1. Well, in this case, it was at x equals 1. So first of all, they told you that f as a function of u was u to the fifth plus 1. So we could take the derivative of that, and that would just be 5u to the fourth. The derivative of 1 is 0. And they gave you g of x, or u, which is g of x, is the square root of x. So basically, we would be taking the square root of x to the fifth plus 1. That's what that would work out if we put this in there. That would be the square root of x to the fifth, or x to the 1/2, or it would be x to the 5/2 if you substituted it in and did it straight out like that. But they broke it up for you. So this is my g of x. So this is the derivative of x to the 1/2 is just going to be 1 over 2 times x to the 1/2. So that's g prime of x. And I'm going to need these different components. All right. So I have g of x, g prime of x, and then f prime of u. Because remember, if we look at this is the derivative of this composite function. That's the same thing as the derivative of, remember, the composite is f circle g is just, or fog they call it, is just f of g of x. So if we take the derivative of that, we have to use the chain rule, which means the derivative of the outside function evaluated at the inside function times the derivative of the inside function. And this is going to be at x equals 1. So we're going to need all these components, so we kind of figure out what all of our ingredients, and then we mix it up at the end using the chain rule. So at x equals 1, g of 1, up here g of x is the square root of x, that's just the square root of 1, which is 1. All right, g prime of 1, g prime of 1, well, that's just 1 over 2 times the square root of 1, which is just 1/2. And then I'm eventually going to have over here f prime of this, g of x. Well, g of x, or g of 1 was 1, so I'm just going to eventually take f prime of 1, which is going to be 5 times 1 to the fourth, which is 5. So I kind of figured out my three different components I would need here. In other words, I'm going to need this g of 1, and then I'm going to need f prime of whatever that is. All right? All right, so if I put 1 in there, that's 5, because g prime of g of 1 was 1. So if I put 1 in there, I get 5, and then I need the g prime of x, and the g prime of 1 was 1/2. So we put this all together. So you have all of your ingredients. It's like you're cooking a souffle, and you put all your different ingredients together to get everything, then you put it all together. All right, so this is what we had. This is what we were trying to really find, the composite function, the derivative of that at 1. By the chain rule, that's going to be f prime of g of 1 times g prime at 1. So f prime of the inside, the derivative of the big function evaluated at the inside function times the derivative of the inside function. And we found all these components. G of 1 over here was 1. So that goes inside here. G of 1 is 1. And then g prime of 1, g prime of 1 was 1/2. And then what's f prime of 1? F prime of 1 was 5. So that becomes 5. So I have 5 times 1/2, which is 5/2. So you're just kind of taking your ingredients and putting them all together. So basically you need three different quantities. You need the inside function evaluated at this, the derivative of the inside function evaluated at this, and then the outside function evaluated at whatever this is. In this case it was. Okay, and let's take a look at 35 so we can see a little bit more of this type of stuff. This is a little more complicated one also, so to be patient about this. So this is my outside function. F as a function of u is cotangent of pi u over 10. So if I take the derivative, what's the derivative of the cotangent? Negative the cosecant squared of this function. But this function actually even had an inside function, because the derivative of pi times u over 10, which is like pi over 10 times u, is just pi over 10. So we actually had a chain rule over here. So this was my outside function. I had to take the derivative of it, the outside function, which was a negative cosecant squared of pi u over 10, times the derivative of pi u over 10, which is just pi over 10, because that's like a constant, pi over 10. Okay, and then we just put the pi over 10 in the front. So we simplified it so it'd be a little bit easier to deal with. And then my u of g, which is equal to g of x, my u g of x, was just going to be 5x. And if I take the derivative of, 5 times the square root of x, this was given. G of x is 5 times the square root of x. And then if I take the derivative of this, the derivative of the square root of x is just 1 over 2 times the square root of x. So that's just 5 over 2 times the square root of x. And then again, as we said, this derivative is the same as the derivative of this composite function, which is, by the chain rule, the derivative of the outside function evaluated at the inside function times the derivative of the inside function. So again, I found my ingredients. So I needed g of 1, because that's going to go in here, because we're evaluating at x equals 1. So it was just 5 times the square root of 1, which is just 5. And then eventually I'm going to take f prime at g of 1. So f prime was this function. And I evaluated at g of 1, which is 5. So instead of putting the u here, which is what it was had a u here. Instead of putting that u there, I'm going to put 5 because I'm going to evaluate that at 5. That's f prime at 5. So to think about that, so f prime at 5 is going to be negative pi over 10 cosecant squared of 5 times pi over 10, and then 5 over 10 is 2, so it just ends up being cosecant of pi over 2 with pi over 10 in front. So if I put the negative pi over 10, and then I rewrite this in a more functional notation, the cosecant of pi over 2. Well, the cosecant is the same thing as 1 over the sine. The sine of pi over 2 is 1, so that's just going to be 1 squared, which is 1. So this is the evaluated. So this is the derivative. The outside function evaluated at 5, which was the value of the inside function at 1. So can I keep track of all this stuff? And then finally, I want to take the derivative of this. And the derivative was 5 over 2 times the square root of x. But I'm going to evaluate that derivative at 1. So that's going to be 5 over 2 times the square root of 1, which is 1, so it's just 5 halves. So there we go. So now we're going to put it all together, and we're going to evaluate this composite derivative at 1. So that's going to be, by the chain rule, the derivative of the outside function evaluated at the inside function times the derivative of the inside function. Well, the outside function, this was this one. Well, I'm sorry, g of 1 was equal to 5, so that goes in here. And then I've got to evaluate that, so I put the 5 in there, and that's where we got the negative pi over 10. And then g prime of 1 over here is 5 halves, so we just substitute it. Okay, so again, these were the three quantities we needed. This, and this. So I found those over on the side. And then after that, that becomes negative pi over 10 times 5 halves. And 5 over 10 is 2, so it ends up being negative pi over 4. So that's how it kind of simplifies out. Okay? All right, so that was okay, number 37. I'm sorry, number 35. And let's see, we'll save the other one for one more video.